Introduction to Arduino programming and simulation using Arduino IDE and electronic simulation software. In this tutorial, we're going to be using the Arduino IDE and Proteus PCB design software and circuit simulation software. So we're already trying to install Proteus. While we wait for Proteus to install, we'll install the Arduino IDE at the same time. So let's agree here. We'll agree and click install so that the Arduino, both of them can install simultaneously. So let's wait while we install the two. We'll talk about basically for you to work on Arduino, you have to have the Arduino hardware, but here we'll be using the simulation software. So let's open Proteus, and this is the Arduino IDE. This is the blank page of the Arduino IDE, and this now we'll try and create an Arduino project under Proteus. So let's create a new project. Let's call it Arduino project. Let's call it Arduino project. So well, everything's going to be default. We're not creating a PCB and we're not creating a firmware. So next. So now we'll try and add Arduino to our Proteus now. So let's go to the Proteus library. We'll search for Arduino. You can see that we can't find Arduino in the Proteus. What we can find is the pin layout of Arduino. We need to add the Arduino microcontroller itself so that we can program it with the Arduino IDE and can simulate whatever we need to simulate. So let's add the library. So we extract the file. We open where our any file extraction file. So extraction software. When we open, we extract to desktop. Then so I'm going to cut it now and paste it inside the Arduino library. So we'll go to C, local disk, program data, lab center electronics, Proteus 8 points. Then we'll go to library and paste it there. With this, we'll be able to add the Arduino library so that we'll be able to simulate Arduino with Proteus. So I think we've already done that now. So let's move forward. So let's open our Proteus now. Now we should be able to add Arduino to our project. So let's open our recent project. The other project that we opened, then we'll open the project. So let's go back to our library. We'll pick a component. So let's tap Arduino. So we'll see now that with the library we copied was from Simonino. You can see there are different Arduino board. There we have Mega, Nano, Uno, and Uno SMD. There are a lot of Arduino board, but here we'll be using the Arduino Uno. And this library was created by someone called Simonino. We know we talked about Arduino being an open source software. That means everybody can add to the Arduino platform. That makes it easier and simple. So now we'll be making use of the Simonino Arduino Uno, which is almost similar to the real life Arduino IDE. So now we add LED. We want to create a circuit that can turn on and off LED. Then we add our power supply. So everything is inside Proteus. So let's add power supply. Okay, battery. Okay, this is a 12-volt battery anyway, but we can always change it to 5 volt. So it has been added now. So yeah, let's place our Arduino on our sketch now. Sorry, okay. Place the Arduino on our schematic. So this is the Arduino Uno. Arduino Uno needs to be powered with 5 volts. So let's add our LED. So we'll be adding the LED to the input pin and the general purpose input and output pin 8 of the Arduino. So, and we'll be adding our battery to the 5 volt input of the Arduino. So I will zoom in. So let's change our battery to 5 volt. This battery acts as our power supply. We're actually simulating real life scenarios, so we can use whatever we have to get whatever we want. Our battery is 5 volt already, so we'll connect it to the power supply pin 5 of the Arduino. So I will connect the other points to ground, to general ground. So let's connect. So let's connect our LED to pin 8 of our Arduino. But first, let's place our ground. Our ground, which is the same thing as the negative terminal. So we'll place the ground for our battery, which is the negative, and we can also place the ground for our Arduino so that it will be easy. So rather than have a long wire connection, we can easily do that. So let's add the input pin 8. Let's connect our LED to the pin 8 of the Arduino. I will connect the anode, the cathode of the Arduino to our ground terminal, which is common, so that it won't be confusing. So We've done that now. So we'll try and simulate now. But the good thing about we simulate now is this is just a bare board that hasn't been programmed. So our simulation, let's see what will happen. You can see the simulation didn't start because the board has not been programmed. So we'll now try and write program for our Arduino using the Arduino IDE. So let's launch the Arduino IDE. So Arduino has the Arduino's IDE come with a lot of sketch. What is sketch? Sketch is Arduino program. So we'll go to example, file example, and select basic example, which is blink. That we can blink. We can create a blink program that can blink the LED. But on this what's it called? On this program, we can see that the pin that is there is called the LED pin. So I just try to increase the indent. So we're not using the LED built-in pin. Most Arduino has a built-in LED on the board, but since we are using a soft Arduino IDE, that means a simulated Arduino IDE and not a real life Arduino IDE. So we won't be having access to the onboard LED. So we'll change that to our pin now. So we're setting our pin, instead of using the LED built-in, we change it to pin 8 because we connect our LED to pin 8 of the Arduino board. So after that, so we set it like that. What was telling the program now is that we're setting digital pin 8 to make it an output pin. One thing about Arduino is that most pins that can work as input can also work as output. So after setting it in the void setup that okay, pin 8 should be output, we'll now tell in the loop is constantly running. We'll tell it okay, set pin 8 high, that means on, wait for 1000 milliseconds and set it low. So pin 8 low, another 1000 milliseconds. 1000 milliseconds equals to 1 second. So now what we try to do now is to export our sketch. So we have to save it first before exporting. So let's call this my blink project. So and save. So let's export sketch again so that we can be able to use it for our Proteus. So it will compile. So it's already compiling. So it's not compiling now. So we can go back to our desktop and verify what we did. So let's go back to our desktop and verify. So we can see it's already on our desktop. So what we need to do now is to add it to our Proteus. We'll add it to our Proteus. You can see we have the program and we have the X file there. So let's open our example. Oh, this thing didn't save, so we have to create our sketch again. It's a mistake. Okay, it's back now. So we go to edit properties. Edit properties, then program file. So we have to tell the Proteus the location of the program so that it can read the program and perform what we want it to perform. So we'll select the X file. Okay, so let's simulate. Everything is set now, so let's simulate. So let's click simulation. You can see the 8 is turning off and on, but our LED is not coming off and on. I think there's a problem somewhere. Okay, I think we used the wrong LED. It's the wrong LED. So I've already changed the LED now. I've already added the new LEDs. The LED we used earlier was what's it called? Was a symbol. So we want to add the real LED from the library. So these are real animated LED now that we can use that can actually show us what we want. So we'll be adding it now. Our program still remains the same and our pin still remains pin 8. So we added an animated LED now so that we can see how the circuit works. So we can see now it's already turning on and off for 1 second. On, off, on, off. That's basically the result of the program we wrote. So we'll do more. I will be adding more LEDs. So I've added like 3 LEDs now, red, yellow, and blue, and we'll be turning them on one after the other. So everything is connected to pin 8, 9, and 10, and I'm giving them a common ground terminal, which is the negative terminal. Common ground. So go back to the program. Let's save this. Oh, I mistakenly closed it. So we're back. So each of the LEDs is connected to pin 8, 9, and 10. So let's go back to our Arduino and write a new code. So what we'll do is we'll set up the pins. So we'll use something called integers. That means integer for the pin. So integer blue is equal to pin 8, integer yellow is equal to 9, and integer red is equal to 10. That means we are assigning values, names to the pins so that it will be easy to make use of them wherever we're going to make use of them. We've added it now. Blue is 8, yellow is 9, and red is 10. We can see from our Arduino program. So let's go back. So we have to change it here. So since 8 is blue, so we're doing red first. So red. So in the first program, red will be high, the rest will be low. Yellow will be low, blue will be low, red will be high, and we'll wait for 1 second. Then in the next cycle, red will be low, yellow will be high, blue will be low. So we're trying to turn off red, yellow, blue one after the other, one at an interval of 1 seconds each. So you can see what I did basically was just to copy and paste and change the value from high. So the first one, red was high, second one, yellow was high, and third one, blue was high. So let's export the sketch. Okay. So now there is an error. Arduino said we have an error. I think the mistake I made was I didn't put an indent. So that's the beauty of Arduino IDE, which will tell us if we have an error. So let's indent it. Okay. And at the same time, we're supposed to set the pin mode and tell Arduino that all the pins are output pins. Blue output, yellow output, and red output. We have to tell Arduino that the pins we're using that they are output pins. Okay. Let's compile. We're still having the same error. Okay, I think the problem we had was we declared the integers inside the loop or set in the void setup and not the general, and we didn't make it a global variable. So what basically happens is that it's only the way we did it before. It's only void setup that will make use of it, and loop won't be able to make it. And that's why loop is saying we haven't defined it. So what I did now was to make it global. That means it will be at the beginning of my program, even before the void setup and the void loop, so that everything can make use of it, including the void loop and the void setup. Anything that is in loop we keep circulating, and everything that is in setup we only run once. So now I've made it global. Let's export sketch again and compile. It's already compiling. It's not compiling now, so let's go back and simulate. Let's edit first and add the sketch to our program. Okay, so let's simulate now. Yeah, you can see now red, yellow, blue, red, yellow, blue, red, yellow, blue. So that's basically what we did. So I will go back to the sketch now and I will edit. I want to reduce the time. The time was 1 second, so I will be reducing it to 500 milliseconds. We just have a second each. So I will see what will happen. So our program remains the same. The only thing we need to change is the time. So I think you understand the program from the beginning. We define the integers, assigning names to the pins in the global page, and then we set the pin mode for all the pins. We make them output them. For the first cycle, red was high, second yellow was high, and the third blue was high. So the rest were low. So and we set the time now to 500 milliseconds. So our program will run faster now. So that's it for the blink LED control. You can see it's running faster. We can even increase this time as much as we like to even around 1 millisecond. So in subsequent course, we'll be attaching an oscilloscope to see how the time affects the pulse width of our digital signal. Thank you. Have a wonderful time.